Alright, the planet Omicron, the acceleration of a falling object is 45 meters per second. Oh, look at that good stuff. That's amazing. Blah, blah, blah. Alright, the distance the object is from the ground at any time t. Well, see when that does that. Remember that we have the position is s of t. Its derivative we called v of t. And what was the derivative of velocity? Acceleration. Very good. So by saying that the acceleration of a falling object is 45 meters per second, that means a of t is 45. So since the derivative of velocity is acceleration, if we find the antiderivative of acceleration, we get velocity. We're going backwards now. So v of t, I'll write it here, would be the antiderivative of a of t dt. So this would be the antiderivative of 45 with respect to t. Well, remember that's 45 t to the 0 from what we did. So since everyone has a 15.1 master by now, what is the antiderivative of 45 with respect to t? Plus c. Don't forget your plus c. 45t plus c. So remember that's really 1 over 0 plus 1, t to the 0 plus 1. Is that okay? Remember that? Monday, you were here, I was here. We talked about that thing. All right. But notice it says an object is thrown down at an initial velocity of 45 meters per second. Meaning that at the beginning of time, the velocity is 15. So if it's the beginning of time, what does that say about t? T is 0. And if the corresponding velocity is 15, what does that say about v? V is 15. So this is like our marginal revenue we had last class. So this says v of 0 equals 15 equals 45 times, what's our t? 0 plus c. Well, notice this says c equals what? C equals 15. Because remember, by having a plus c there, you have infinitely many answers. We need the one where the initial velocity is 15. Okay? So what is our real v of t? 45t. And we just found c to be 15, plus 15. Now here's the hitch. Notice the object is being thrown down, which means it's getting closer to the ground. In other words, the distance from the object to the ground is decreasing. So right now, since time is always positive, or non-negative I should say, that would make our velocity a positive number. We don't want a positive velocity. We would want a, if the distance is decreasing, that means velocity is negative. So what should we do to our velocity to say, hey, it's really going the other direction? Make it negative. So our real velocity, let me erase that real quick. Our real velocity is negative 45t minus 15. You have to negate the entire thing. And now it says, by the way, we're almost to part A, because the distance is s of t. So if the derivative of s of t is v of t, if we know v of t, how do we get s of t? Take another antiderivative, yeah. So s of t is the antiderivative of v of t, dt. I'm going to move this line over to get some room. Hope no one's offended by that. So that would be the antiderivative of negative 45t minus 15 with respect to t. So if you would, please find the antiderivative of negative 45t minus 15 with respect to t. So we have two instances of the power rule here. So what's your final answer? So again, this would be negative 45. Pull that out. What's the n here for the first term? 1. So 1 over 1 plus 1. T to the 1 plus 1. And then that's minus 15, really t to the 0. So 1 over 0 plus 1. T to the 0 plus 1. And then what do we tack on? Plus c. There it is! I'll just sit down. Negative 22.5, or you can say negative 45 halves, t squared, minus 15t. I like this sitting down thing. Plus c. Great. I should teach like this all the time. But notice this is a general position vector, and it doesn't say when the building is 2,500 meters high. So that information is how we get our c. So again, this is at the initial. So t equals 0 when s equals 2,500. Very good. Because s is the height off the ground. So we'll have s of 0 is 2,500. And that equals, sorry for the break there, negative 2.25. Oh, I'm going to have to put that, oh my gosh. So negative 22.5 times 0 squared minus 15 times 0 plus c. Now you might be like, hey, it keeps turning out that c is that number all the time. So in this case, notice c is 2,500. Is that always going to be the case? No. You actually have to go through this each time. Because we were lucky here and we got initial. The word initial means time equals 0. However, if they said after 1 second, the height off the ground was so-and-so, then you'd put in t to be 1, and you wouldn't get 2,500 in for c. So please be careful with that. So what is now our position function, our s of t plus 2,500? Very good. That's part A. Part B, the time at which the object hits the ground. So the acceleration is 45 meters per second. You threw it down at 15 meters per second. Like if there was like a police radar system, they saw how fast your hand moved, that'd be the 15 meters per second. And now you're going to wait at the top of this 2,500 meter building, which is pretty big. And it's over a mile. Yeah, that's over a mile. Way over a mile. So good job, Planet Omicron, on buildings taller than a mile. Yay. And you want to know how long it's going to take to hit the ground. Well, when something hits the ground, what is its height off the ground? 0. So for part B, instead of s of t there, you're going to put 0. So some of you may have had, I don't know, an application in your calculator that does the quadratic formula. But I actually want to see the work here, because this doesn't factor nicely. So if you would, please find what t equals, using your friend, the quadratic formula. I can't fit it over upside down smiley face. You're going to get two answers for t, one positive, one negative. Time can't be negative. So we just take the positive one. And if you would, round your answer to 2 decimal places. All right, we need to get this party going. I got 10.21.